Hello everyone. So in this part 3 lecture of the pneumonia, we will discuss about the community acquired viral pneumonia, which is also formally known as an atypical pneumonia. So let's discuss the etiological agent for the development of viral pneumonia first. So the common etiological agent is influenza virus, particularly type A and B. Second etiological factor is respiratory syncytial virus, then human metapneumonia virus, then adenovirus, then rhinovirus, then rubeola virus, and varicella virus. So these are the etiological factors for the development of viral pneumonia. And the risk factor and the causes are same like that of bacterial pneumonia. We have discussed it in the part 1 and 2. Pathogenesis also has been discussed, right? Alright, so we will not discuss that part. You can check the playlist and see that videos. Alright. Alright. Now let's discuss the morphology of viral pneumonia. So friends, in the viral pneumonia, lungs are consolidated as like that of bacterial pneumonia. The lungs are formed, red and the congested because of inflammation, right? Now here the characteristic feature in the morphology of viral pneumonia is there is a presence of interstitial inflammation. The inflammation is mainly in the interstitium. So that is the predominant feature of the morphology of viral pneumonia. And in this particular condition, in the interstitial inflammation, particularly alveolar wall and the septa are involved. That's why it is known as an interstitial inflammation. And alveolar septa and the alveolar wall will be widened in this viral pneumonia. They will show the edema. And there is a predominantly mononuclear inflammatory infiltration. Mononuclear inflammation means there is a presence of lymphocyte, then macrophage, and plasma cell. So this mononuclear inflammation is present in the viral pneumonia. All right. Now there could also be presence of intra-alveolar proteinaceous material deposition. In between the alveoli, in the alveoli there could be presence of proteinaceous material deposition, and sometime like that of bacterial pneumonia, cellular exudate also can be seen. So that is another feature of viral pneumonia. And if viral pneumonia is severe, suppose the viral pneumonia is severe, then the patient can develop acute respiratory distress syndrome like that of COVID viral pneumonia, right? And in the ARDS, acute respiratory distress syndrome, there will be presence of pink hyaline membrane formation that will line the alveolar wall. So lining the alveolar wall, there is a presence of pink hyaline thick membrane if the patient develop ARDS. All right. Now, in the viral pneumonia, there could be reactive changes in the cell. It can mimic like that of malignancy. Reactive change can be seen, and sometimes inclusion also can be present. Atypia, high NC ratio like that of reactive change can be present. Hyperchromasia, right? All right. Now, see in this diagram, you can see a interstitial inflammation, alveolar cell hyperplasia, nuclear inclusion, and necrotizing bronchiolitis, which can be observed in viral pneumonia. Now let's see the clinical course of viral pneumonia. What is the clinical presentation? So the patient can have extreme, the clinical presentation is extremely variable. Patient can have fever, muscle pain, then joint pain. All right, the patient can complain of malaise and anorexia. Patient doesn't feel any appetite. Patient can feel weakness. Cough can be seen or absent, but usually cough is absent in typical viral pneumonia. And if the cough is present, it is dry. Exudate is not present. There could be development of secondary bacterial pneumonia. Secondary bacterial pneumonia can be developed, and that is the more dangerous. Patient can die because of development of secondary bacterial infection. And the viral pneumonia is having the epidemic potential. That is the main danger behind the development of viral pneumonia. It can spread to the community. Epidemic and pandemic potential is there. Now let's see some of the detail of influenza virus. Type A and B variety of influenza virus can cause pneumonia, and particularly type A is the major cause of pandemic and epidemic. All right. Now, uh, you know this influenza virus, the genome of influenza virus, can encode many protein. Genome of influenza can encode a many protein, but the most important, they can encode a many protein, but the most important for the viral virulence, the virulence power of the virus, influenza virus, is because of mainly two protein. One is heme agglutinin, and second protein is neuraminidase. Don't forget these two protein. This is the most important for the viral virulence, heme agglutinin and neuraminidase. Heme agglutinin further can be divided into H1, 2 and 3, while the could be of N1 and N2. All right. Now friends, this heme agglutinin protein will help the virus for the binding. It help in the binding the viral envelope to the host membrane. Virus can bind with our host cell membrane with the help of heme agglutinin protein. So it's function in the binding of virus protein, and after binding, so that virus can release their RNA into the host cell. Because of such binding, they will release the protein, they will release their RNA into the host cell. Now you might have questioned, what is the function of neuraminidase protein then? So the main function of neuraminidase protein is they will help in the release of newly synthesized virion. They will help the virus for the release of newly synthesized virion. They synthesize the new virion in our cell, and that will be released with the help of neuraminidase. All right. Now, one interesting fact is that in the influenza virus, sometimes spontaneous mutation can occur, so that there will be alteration in the antigenic epitope on the heme agglutinin and neuraminidase protein. Over these two protein, antigenic epitope will be changed, will be altered because of mutation, and because of which the new strain will develop. Virus change their structure. The new viral strain develop because of change in the antigenic epitope by the mutation, and that is known by the name antigenic drift. It is an antigenic drift, and that can lead to development of epidemic. It can lead to epidemic of the influenza virus. But one interesting fact is that sometimes this virus will not, there will be no mutation, but sometimes this heme agglutinin and neuraminidase protein will be replaced by recombination with the animal influenza virus. So this influenza virus will bind with the animal influenza virus, and this condition is very disastrous. If the total structure of influenza virus is changed by recombination with animal influenza virus, then it is known by the name antigenic shift, and this antigenic shift is a result will lead to development of pandemic. You might have heard about the swine flu spread in the world, in the 2009. That is the example of antigenic shift. right? So antigenic shift will lead to pandemic. It has a pandemic potential. All right. Now, what about the coronavirus? So you might have heard lots of things about the coronavirus. It's a SARS-CoV-2 and highly pathogenic virus. It emerged in the China. It emerged in the China in the late 2019, right? And this virus, the main pathogenesis is that they will bind to the angiotensin converting enzyme receptor 2 on the alveolar epithelial cell, and so they will lead to development of pneumonia. They will damage your alveolar epithelial cell by binding with ACE2 receptor. In that way they will lead to pneumonia development. It can commonly lead to ARDS development as well, acute respiratory distress syndrome. And the main feature of this virus is that it can lead to cytokine storm, and so patient can develop thrombosis. Patient can undergo DIC. Thrombosis can be developed. I have already made the video on the coronavirus. You can see the details of coronavirus in that. You can check the playlist. All right. Now, friends, what do you mean by atypical pneumonia? Initially, atypical pneumonia was equivalent to viral pneumonia. Atypical pneumonia is a walking pneumonia. Why? Because generally, hospitalization is not needed in atypical pneumonia. Hospitalization is usually not needed. In this particular condition, lungs are congested. As it is pneumonia, lungs obviously congested because of inflammation, and there will be presence of interstitial pneumonia, as we have discussed earlier as well. Like that of viral pneumonia, here you will have interstitial pneumonia. Alveolar wall and septa will be widened and infiltrated by mononuclear inflammatory cell. Usually, there is a lack of alveolar exudate. Exudates are usually absent, and consolidation is also usually absent. That's why it is not much severe and hospitalization not needed. The most common cause for the development of atypical pneumonia is mycoplasma and chlamydia. Most common one is mycoplasma, and other one is chlamydia virus. All right. So that was about the atypical pneumonia. So by this, we are ending up with a pneumonia. Hope you have enjoyed the part 3 of pneumonia as well. Thank you very much and see you soon in the next video. Till then, take care and bye bye.